Hi everyone, in this video we're going to go through 14a, the Bernoulli sequences and the binomial probability distribution. So in chapter 14, quite a short chapter, just focusing on the binomial distribution, but you don't really have to know too much about the Bernoulli sequences, not too sure how to say that. Basically, it just means that you have an event that has success or failure, and it's consistent. So it's the same for every trial. So the examples I've got on the screen, so flipping a coin, when you flip it, it will always be 0.5 for a head or 0.5 for a tail. Okay, it is consistent, it is the same every time. So that means that for a Bernoulli sequence, the events are independent. It doesn't matter what happened before. So the same as rolling a die. So if we wanted to roll a 2, the probability is 1/6. And if we didn't want to roll a 2, it is 5/6, and that does not change. The other example I've got on there is selecting a ball with replacement. So let's say we had a bag with 8 blue balls and 2 white balls, and we took a ball out. Okay, that reduces how many balls we got in that bag. Okay, so from 10 down to 9. But if we put that ball back, we're back where we started, and the probability is the same. So that means with replacement is independent, but without replacement is not independent. So that's why it's important that we say that we've got with replacement there. So let's focus on the binomial distribution, because that's pretty much what this chapter is about. The binomial distribution, it looks very complicated, and sometimes maths looks more complicated than it needs to be. So with this binomial distribution, as long as you can identify these values, so let me just get my highlighter up, come on. Okay, so as long as you can highlight, where are we, n, okay, x, and P, and if you can identify P, you can also identify Q. So these 4 numbers might not be explicitly given to you in a question, and when we look at some examples, you'll see what I mean by that. It will say, if we're shooting goals, okay, we're playing basketball, and we have some foul shots, and out of 20 foul shots, how many, what is the success of getting 15 in? Okay, so your number of trials would be the number of times you go for goal or go for the foul shot, so that's 20. And X is the number of times with a specific outcome, so 15 for that one. P and Q is the probability of success and the probability of failure. Because we're only looking at an event as having 2 possible outcomes, success and failure, you've got your probability of success, and then 1 minus that will give you Q. So you can always calculate Q even if it's not given to you. Now this funny notation here, all right, is the same as this, all right? So we usually say N choose R. In this binomial distribution, it's N and X. And there's a button on your calculator that you can use for that. But you don't really need to use your calculator or understand what this means. Okay, so that's just how you calculate your combinations. So NCR, number of combinations, that's using factorials. You don't need to know that. So let's get the calculator out, and I'll show you where these buttons are. Okay, so first of all, NCR. All right, so combinations. So I was already in the screen. So let's go back to this main screen. So you know where this keyboard is, and you use most of these, okay? But if you go down, there's actually a few more. So if we just go to advance, and then you can see it there, and choose R. And then you would just write your value of N first, comma, R. And you can see there I've done a question previously. But the good thing is your calculator will just do the binomial distribution for you. So even though in the binomial distribution, we do have the combination, yeah? Okay, and we write it like this without the C. The calculator does it for us, and we'll go through the steps for that in a second. Okay, so I've just put these two boxes in. Okay, so this one here is basically just highlighting everything you need to know. Hopefully we'll soon know. But I thought it was important just to show what the combination actually means. So this bit here is the same as this bit. Oh, lots of highlighting. Okay, so let's move on to some questions. So here we've got a example. So find the probability of obtaining exactly 3 heads when a fair coin is tossed 7 times, correct to 4 decimal places. So what you need to find, let me just get my pen, is the value of n, your value of x, and your value of p. All right, they're the 3 things you need. And you can see the calculator down the bottom, and it's a little bit small, so I might just make it a bit bigger. All right, you can see on the calculator screen here, it's asking for x. It doesn't say n, but it says number of trials. So n is the number of trials. Okay, so it's n, and POS, probability of success, so p. All right, so those 3 things you put into your calculator. So from this question, and the questions you're going to be asked will never say use the binomial distribution to blah, 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 blah. So you need to be able to identify when to use your binomial distribution. The most obvious giveaway is if they're independent events. Okay, so that just means that the probability of success does not change. All right, so here we've got, and if you've got a number of trials and you need to know the probability success of a certain number of those trials, then that's another giveaway. So today's Saturday, yesterday, Friday, you did a VCAR quiz with some binomial distribution questions. So that you would have seen then what sort of questions you would be asked. Okay, so slightly different to this one, but still fairly similar. All right, let's get started. So we want exactly 3 heads when a coin is tossed 7 times. Okay, so exactly 3 heads. So that's going to be our value of x. Toss 3 times. So it's going to be our value of n, and it's a coin. So we know a coin has either heads or tails, so the probability of success is 0.5. Now putting it into your binomial distribution, you can see all the values here. So same binomial distribution that I highlighted in yellow up here. All right, it's just been written down here. So we've got n, x, p. Now remember, q is 1 minus p. And then we've got the value of x here, and this power is just n minus x, so 7 minus 3. So your 2 powers have to add up to your number of trials, because you're effectively wanting, for this question, 3 successes and 4 failures. So you have to allow for each trial. Okay, and then you just do that on your calculator. This working out here, you don't really need to do. Oh, actually what they've done is 0.5 and 0.5. So you had the same basis. That's why it's 0.5 to the power of 7. But here we go on the calculator. So let's just quickly do that on the calculator. Grab the calculator. Okay, so we go to interactive. Now all these instructions are actually on the left side of the screen. Distribution, discrete. So we're only looking at discrete variables at the moment. And you can see you've got 2 types of binomial, PDF and CDF. We want PDF if we're just looking at one number. Soon we'll look at CDF, very soon. I think it's coming in the next question. If you choose the wrong one, you'll soon know because you get different screens. All right, so let's type in 3, 7, 0.5. Okay, and you can see you get the same answer as the textbook, which is pretty good. All right, moving on to example 3. So this example, we are now looking at a range of values. So before we wanted to know the probability of getting 3 heads, exactly 3 heads. For example, number 3, we want at least 3. So I can see that in the question, at least 3. All right, so let's read the question. So the probability that a person is currently in prison, has never been imprisoned before, is 0.72. So remember that what we're looking for is N, P, and X. All right, so that's all we need for our calculator. For this question, we've got a lower bound and an upper. So when we were doing some questions yesterday, it was important to, or it probably wasn't yesterday for you, but when we did do the VCAR question, it was important to identify the lower and upper and not just go straight ahead and putting it into your calculator, because if you get the wrong number, you get the wrong answer. Okay, so we've got 0.72 as our probability of success. So probability that they've been in prison before. Find the probability that 5 prisoners chosen at random, so 5 prisoners, at least 3 have been imprisoned before. So at least means we want 3 or more. So our lower limit is 3 and our upper limit is 5. So the upper limit comes from we're going to be only interviewing 5 prisoners, so we can't have more than 5. Now with your binomial distribution, you can see they've included the values from 3 to 5. So we want basically 3, 4, 5. So that's done here, 3, 4, 5. But you don't have to go ahead and do each one individually. Quite time consuming, and your calculator does it for you. So here we've got the instructions for the calculator, but I might just go ahead and do it. So interactive, distribution, discrete, and this time we want binomial CDF. Okay, so we're looking at a range of values. We're going from 3 to 5. The number of trials is 5, and our probability of success is 0.72. So go OK, and then we get our answer. Okay, most of the probability questions are to 4 decimal places, so just be careful with your rounding. All right, example number 4 is combining the two of them to be a conditional probability question. So when we did the VCAR quiz on Friday, we did a few conditional probability questions, and I said it's important to understand when it's a conditional probability question. So usually when it says given that, that's a hint that it's a conditional probability question. All right, so the probability of a netballer scoring a goal is 0.3. Find the probability that out of 6 attempts the netballer scores a goal. So we want first of all 4 times, and then 4 times given that she scores at least 1 goal. So the term given that should kind of indicate in your brain, it's conditional probability. And the condition follows the term given that. Okay, so when we did those questions yesterday, they're kind of around the other way. All right, so those VCAR questions were around the other way. So you've just got to be careful that the condition follows the given that. All right, so our value of N is 6. So she's got 6 attempts at goal. X does change. So for question A, X is 4. But for question B, we have a range of values. So I'm just not going to write X at the moment. And our probability of P is 0.3. So not a very good netballer. Sounds like me when I used to play netball. Although I didn't play shooter or goal attack. I played in defense, so I'm allowed not to be a good shooter. Okay, so question A, we want 4 goals, exactly 4 goals. So you can see the placement of the numbers. So N, X, P is 0.3, making Q 0.7, and their powers. All right, so you would just do that on your calculator. With question B, I'm going to talk about that one a bit more because we haven't done conditional probability with binomial distribution, but it's not that hard. Okay, if you're okay with conditional probability, you'll be okay with this. So we want, I might just use my highlighter, the probability that x equals 4 given that x is greater than or equal to 1. So we want at least one goal. Now what they've done in this question, okay, so first of all, here we've written, or they've written their conditional probability formula. Okay, just substituted the values in, so x equals 4, and so we want to find the intersection between x equals 4 and x is greater than or equal to 1. So the only thing that those two have in common is x equals 4. And then on your denominator, you have the condition, so x is greater than or equal to 1. What they've written over here, and you don't need to do this because you're doing it on your calculator anyway, but you might be thinking, well, why have they written this and not done it on the calculator? Sometimes you can calculate probabilities by doing 1 minus what you don't want. What you don't want. All right. So in this case, we want x to be greater than or equal to 1, so at least one goal, but we don't want 0 goals. So you can see there 1 minus x equals 0. But on your calculator, you can just do, oops, that's not my calculator. That's not my calculator either. I keep choosing, oh gosh, come on. Okay. Okay, so first of all, we want, I'm just going to do this quickly, discrete. So we want PDF. Okay, so x is equal to 4. And number of trials, how many times did she go for goal? 6. And 0.3 for probability of success. Okay, so we've got that. I'm just going to leave it there. Now don't go rounding until the very end. Come on. Okay, so our lower limit, so she wants at least one goal. So we've got 1. Come on, write the number 1. Why isn't it working? There we go. 1, 2, how many goals is she doing? 6, 6, and 0.3. All right, so we've got our 2 values here. So all I need to do is I can highlight it, drag it down, divided by, highlight, drag it down. Just don't do any rounding until the very end, because if you round throughout, your final answer, even if it's like to 4 decimal places, if your 4th decimal place is incorrect, you're not going to get that point on the exam, that mark on the exam. Okay, so leave it in your calculator, use the numbers in your calculator. All right, so let's do some questions. So question 4, for a binomial distribution with n equals 5 and p equals 0.4, find the probability of no successes, 3 successes, and 5 successes. Okay, so first of all, sometimes we don't need to use the binomial distribution, and I'll show you in a sec why. So if we've got no successes, so n equals 5, p equals 0.4, and x equals 0. So we can just go ahead and do that on our calculator. Okay, so what do we got? 0, 5, 5.4. Okay, so, oh, can't you stay on? 0.778. 0.0778. This is the same. Okay, if we've got no successes, you want the probability, sorry, I probably should use a capital P, the probability of, so if we just want to call no successes, let's use it letter F, Q, sorry. I'm trying to think, what letter do we use for failure? So we want Q, 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 Q. If you think of this as a tree diagram, there's only one possible Q, 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 Q. Okay, so that is the same as probability of failure is 0.6 to the power of 5. Okay, so you might see it written that way as opposed to doing the binomial distribution. So if I get my calculator back up, so 0.6 to the power of 5, and you can see you get the same answer. The reason for that is because if I was to, and you don't really need to know this, but the binomial distribution, if I've got 5 choose 0, that is equal to 1. Then my power p, my value p, so times p is 0.4 to the power of 0, because we don't want any successes. Anything to the power of 0 is 1. And then our probability of failure to the power of 5. And that's why we could just do 0.6 to the power of 5. So 5 choose 0 or even 5 choose 5 is still 1. Okay, so when we look at question C, we're going to have 5 choose 5. Okay, so you don't need to do the binomial distribution. You can just do 0.4 to the power of 5. But I'll do that with you anyway. All right, question B, let's just quickly do that on the calculator. Now you can just highlight your binomial distribution. Drag it down. I'm just going to change that 0 to a 3. Just saves us, a bit of time. Frustrating. 0.2304. And question C, okay, so it's kind of like the same as no successes. We want 5 successes. So we want P, 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 P. So the probability of success is 0.4 to the power of 5. Whoops, sorry, wrong thing again. What was that? 0.4. All right, 0.0104. Or was it 2.4? So just 2. All right. Question 7. Okay, so we've got a fair die is rolled 6 times. So n equals 6. The number of 2's noted, so your probability of getting a 2 is 1/6. So for question A, we want exactly 3 2's. So that's the probability that x equals 3. All right, you can just do that on your calculator. We'll do them in a sec. Question B, more than 3 2's. So we want the probability that x is greater than 2. No, 3. Sorry, I'm getting my things mixed up. So more than 3 means we can't include 3. So when you're doing that, you should say your lower limit and at your upper limit. Just identify them just so you don't choose the wrong numbers. So our lower limit, we want more than 3. So it has to be 4. And then our upper limit, we're only rolling it 6 times, so it has to be 6. All right, and then question C is the probability at least 3 2's. So at least, so greater than or equal to 3. All right, so for this one, your lower limit is 3 and your upper limit is 6. Okay, so just be careful with the wording, more than and at least. Okay, so let's get the calculator. So the first one, we only want one value. All right, so we want 3. Number of trials, 6. And the probability of success, you can write that as a fraction, so you can put that in. All right. So anyway, you can write that down. I'm not going to write it down. The next one, got CDF. Okay, so your lower limit is 4, 6, number of trials is 6, and the probability of success is 1/6. All right, so, this question here, okay, so there's our answer. Come back up. All right, so the e to the -3, that's the same as saying times 10 to the -3. So what have we got? 8702. And times 10 to the -3. So if you see e, just do times 10 to the power of -3. And that just means we're moving our decimal place 3 spots to the left. So at the moment it's here behind the 8. So just moving it 1, 2, 3. So you're just putting zeros in between. So we're going to have 0.0087. And if I'm just doing it to 4 decimal places, it's just 0.0087. And then the last one, where's my calculator? Okay, we can just highlight that again, drag it down, and put the 3 there. Okay, what do we got? 0.0622. 623. All right. Question 19. The manager of a shop knows from experience that 60% of her customers will use a credit card to pay for purchases. Find the probability that. Okay, so all the side of the question is given us is that probability of success is 0.6. So for question A, the next 3 customers will use a credit card and the 3 after that will not. So for question A, you can't actually use the binomial distribution. The way the question is worded means that, all right, pretend you're a shop assistant and a customer comes in, uses a credit card. Next one uses the credit card. Next one uses the credit card. So we've had 3 in a row use their credit card. And a 4th person comes in, doesn't use a credit card. 5th person doesn't use a credit card. 6th person doesn't use a credit card. So it has to be that order. So we want the probability of credit, 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 and then not credit, not credit, not credit. It has to be in that order. It's different to part B. So it says 3 of the next 6 customers. So that could be in any order. You could have credit, not credit, credit, not credit, credit, not credit. Okay, so it doesn't matter the order, whereas A, order counts, but this isn't that difficult. Okay, we know that the probability of having a credit card is 0.6. So 0.6 times 0.6 times 0.6. If it helps, picture it being drawn on a tree diagram. You wouldn't do this using a tree diagram because it would be a huge waste of your time and a huge tree diagram. But think of the branches, C, C, C. When you're looking over your branches, you multiply. So 0.6, 0.6, 0.6, and then no credit card is 0.4, 0.4, 0.4, which is the same. Okay, we've got the same bases. So 0.6 to the power of 3 times 0.4 to the power of 3. And then you can just put that into your calculator. For question B, 3 of the next 6. So this is where you would put that into your calculator. So x equals 3. All right, so you can go ahead and do that on your calculator. Pause if you like. I just am conscious that this is being a very long video, so I want to quickly move through. Question C, at least 3 of the next customers will use a credit card. So at least 3 of the next 6 customers will use a credit card. So we want the probability that x is greater than or equal to 3. All right, so we're using binomial CDF. And then question D, exactly 3 of the next 6 customers will use a credit card given that. What does that mean? Conditional probability. All right, so we've got a conditional probability question here. If you need to, go to the formula. So we want the probability that exactly 3, so x equals 3, given that, so here's our condition, at least 3 of the next 6. So x is greater than or equal to 3. Now you did those two values in B and C, but I'm just going to do the notation. So x is equal to 3 and x is greater than or equal to 3 over the probability that x is greater than or equal to 3. Now, what does x equals 3 and x is greater than or equal to 3 have in common? They just have probability that x equals 3 in common. All right, so your value from part B goes on your numerator and the value from part C goes on your denominator. All right, last question, question 22. A multiple choice test has 20 questions, each with 5 possible answers, only one of which is correct. Find the probability that a student who guesses the answer to every question will have no blah, blah, blah. Okay, so we've got n equals 20, 20 questions. Probability of success, so if there's 5 questions and only one correct answer, so it's 1 out of 5, or if you wanted to write that as a decimal, it's 0.2. All right, so no correct answers. This is similar to the previous question with the credit card. Okay, so we can just do no correct answers. So we want Q, the probability of failure, to the power of 20. The probability of failure is 0.8. Okay, so 4/5 to the power of 20. And you can just go ahead and do that on your calculator. Question B, 10 or more correct answers, we would use the binomial distribution. So the probability that x is greater than or equal to 10. All right, so you can use binomial CDF for that. And question C, at least 12 correct answers, given they have 10 or more correct answers. So this is a conditional probability question. So the probability that x is at least 12, so greater than or equal to 12, given that x is 10 or more correct, greater than or equal to 10. Now, just writing this out, so greater than or equal to 12. Oh, that's a terrible 2. I should probably delete that because people will be like, what is that she's written there? No, I feel like my computer's going to... No! Okay, let's see if we can keep going. We're nearly done. All right, so that's a 2. X is greater than or equal to 10 over the probability that x is greater than or equal to 10. All right, so your numerator, all right, what we have on the top is, well, what does x is greater than or equal to 12 and x is greater than or equal to 10 have in common? They only have in common values greater than 12, okay, because this event here doesn't have 10 and 11 included, but this event here has 12 and above included. So x is greater than or equal to 12 over probability x is greater than or equal to 10. All right, so you can do them on your calculator and do your fraction on the calculator. All right, bye guys.